Very good morning. Welcome to today's session about Debye model of specific heat of solids. In previous session, we discussed about Einstein theory for solid, Dulong and Petila of specific heat of a solid, and their drawbacks and their application along with the cases we learned in previous session. Today, the another important concept about specific heat of solids is going to be learned. That is Debye theory for specific heat of solids. We already know what is meant by specific heat. Specific heat is nothing but the amount of energy which required to rise 1 gram of object temperature to 1 degree Celsius. For example, you have 1 gram object. That 1 gram object having certain temperature, for example 24 degrees Celsius. So this 1 gram object degree, which is 24 degrees, if you want to change into 25 degrees Celsius, for that whatever energy is required, that energy is called specific heat. So specific heat will be for solid material, for gas material, and for liquid material will be changing based on the respective parameters. So here Peter Debye introduced this theory in 1912. Debye, sorry, not Debye, Debye. Peter Debye, sorry, not Debye, Debye. Peter Debye in 1912 he introduced this theory in which it was assumed that the specific heat is consequences of the vibrations of atoms of the lattice of the solid, in contrast to the Einstein theory of specific heat. So here, after failure of this Einstein theory is having certain drawbacks. It could not explain some of the assumptions. The Einstein theory is not able to explain some of the parameters. So that's why it was a failure concept. So it has certain drawbacks. To fulfill the drawbacks, in 1912, in the year of 1912, Peter Debye, Peter Debye, Peter Debye introduced this concept. It is quite mismatching from Einstein theory. It is not related to or similar to Einstein theory. It is quite different from Einstein theory. In his theory, his theory is leads to the conclusion. So finally, his theory is concluded that what is that? The specific heat capacity of solid is proportional to the T power 3. In his concept, in his theory is concluded that theory, this Peter Debye theory concluded that the specific heat capacity of solid is proportional to T power 3, is proportional to T power 3, where T is thermodynamic temperature. T is thermodynamic temperature. T is, so this is his conclusion. This is his theory conclusion. His theory conclusion is that the specific heat capacity of solid is proportional to T power 3. So this is Debye concept. So let's Before we are moving to the assumptions of the debate, we need to know what are the drawbacks of Einstein theory. What are the drawbacks of Einstein theory? Let's see. It is observed that at low temperature, at low temperature, there is some disagreement between experimental and theoretical values. At what condition? At low temperature. There is a disagreement between experimental and theoretical value. This is the first drawback. There is a mismatching relation between experimental value and theoretical value. This is the first drawback of Einstein theory. Similarly, in the case of some elements like copper, aluminum, iron, the atomic heat capacity at low temperature decreases more rapidly than that predicted by Einstein. Einstein is predicted something value lower than something value or quicker than something value. There is a decrement in the value of capacity. In the case of some elements, like what are the some elements? The elements are copper, aluminum, iron. The atomic heat capacity at low temperature decreases more rapidly than that predicted by Einstein. Einstein is predicted something, then is compared to its prediction value, there is more decrease, there is more rapidly decrease of atomic heat capacity for certain elements like copper, aluminum, iron. This is also one of the drawback. Another drawback is that it is due to the Einstein assumption. It is due to the Einstein assumption that all atoms of solid vibrate at same frequency. But here it is wrong prediction. Einstein assumed that all atoms of solid vibrate at same frequency. Vibrate at same frequency. So these are the drawbacks of Einstein theory. That is the reason Debye introduced his theory in 1912. It is considered as Debye specific heat theory. Let's see what is Debye theory. The main difference between Debye model and Einstein model is that Debye consider that vibration modes of crystal is a whole. It's a unit. He consider as a whole unit. What is the main difference? Debye model, Einstein model is that Debye consider the vibrational modes of crystal as a whole. The vibrational modes of a crystal as a whole. He consider overall as a system. The vibrational nature of the particle he consider as a whole system. Whereas Einstein stating the point was stating not or stating the point was consider the vibrations of single atom. He consider the vibrations of the atom or the vibration of the particles or the vibrations he consider as a the vibration modes he consider as a atom. He consider as a atom. Assuming that atomic vibrations independent to each other, he also assumed that the atomic vibrations are independent to each other. The atomic vibrations are independent to each other. According to Debye, any solid is, according to Debye, any solid is capable of vibrating elastically in many different modes. According to Debye, any solid is capable of vibrating elastically in many different modes. The frequency varying from one mode to another mode. The frequency varying from one mode to another mode. and the number of modes of vibration of a solid is limited. The number of modes of a vibrations of a solid in a solid, the vibration modes are limited in a solid body or in a solid object. The vibrations modes of vibrations are limited. That means it is restricted. The vibration modes of a solid is restricted. When a continuous solid is subjected to elastic vibration, when a continuous solid is subjected to electric vibration, there are kinds of vibrations are produced. When a continuous solid is subjected to elastic vibration, when a solid is vibrated elastically, it producing two types of vibration. When a solid is producing elastically, when a solid is vibrating elastically, when a solid is vibrating elastically, it producing two kinds of vibration, two kinds of vibrations. One is transverse, the other one is longitudinal, parallel, perpendicular. One is transverse, the other one is longitudinal vibration. There are two vibrations are produced in elastic vibration of solid, that is transverse and longitudinal. The number of normal modes of vibration in a volume V. The number of normal modes of vibration in a volume V is the frequency range. Is the frequency range. What is the frequency range? A new and new place, new and new place d new. The number of normal modes of vibration in a volume V. In a volume V, what is the range of frequency? The frequency range is start from new and new plus d new. New is the initial range, new plus d new is the final range. So the initial frequency is how much? The initial frequency is new. The final frequency is how much? New plus d new. Between these two frequencies, what are the number of modes? The number of normal modes assumed as n of new d new, n of new d new equal to v into 4 pi nu square, 4 pi nu square into d new by c cube. Once again, n of nu d nu equal to v into 4 pi nu square c cube into d nu. This is you taken or we taken as equation 1. What is that? Equation 1. Where c is the velocity of elastic wave, v is the volume, nu is the frequency. N of nu d nu equal to v into 4 pi nu square into d nu by c cube, which we consider as equation 1, where c is the velocity of elastic wave. In solid, both the waves can exist together, and transfer waves have two states of polarization. In solid, both the waves can exist together. Both the waves are what? That is transfer and longitudinal waves both together exist. And transfer waves have two states of polarization. The two waves are longitudinal transfer. Again, transfer waves having two states of polarization. Two states of polarization. So that equation 1 will be changing into what? N of nu d nu 4 pi v of 1 by c1 cube plus 1 by c2 cube into nu square d nu. This is as equation 1. So it will be changing as n of u d nu is 4 pi v 1 by c1 cube plus 1 by c2 cube into nu square d nu. This is as equation 2. Each atom has 3 degrees of freedom. 3 degrees of freedom, and the total number of vibrations. So the total number of vibrations are equal to 3n. Each atom has 3 degrees of freedom, and so the total number of vibrations will be equal to 3n, where Vm is maximum frequency from 0 to point A, so that it will be considered as 0 to integral 0 to Vm. So 4 pi V of 1 by C1 cube plus 1 by C2 cube into nu square d nu, which is considered as equation 3. It is equal to 3n, so it is an equation 3. So the equation 3 is equal to 3 degrees of freedom, 3 degrees of the freedom, and it is integrated from 0 to Vm, 0 to Vm, which is maximum concept. Each atom has 3 degrees of freedom, hence the total number of vibrations, that only I am talking. So each atom has 3 degrees of freedom, so the total number of vibration will be 0 to Vm, sorry, not Vm, that is frequency, nu m, 4 pi V, 1 by C1 cube, 1 by C2 cube over nu square dV, sorry, d nu, which is equal to 3n, which is called as equation 3, where nu m is maximum frequency range from 0 to Vm, 0 to nu m, lower limit to higher limit, and it is after calculation, after integration, it will be considered as what? It will be considered as 4 pi V of 1 by C1 cube plus 1 by C2 cube into Vm cube by 3, which is equal to 3n, which is equal to 3n. After integration, it is considered as the maximum value of frequency, which is nu square. It is considered into nu cube by 3, x to the power of n plus 1 by n plus 1 formula, x to the power of n plus 1 by n plus 1 formula, x to the power of n plus 1 by n plus 1 formula. Here nu m is the frequency, which frequency? Maximum frequency. So here the above equation, which is equation 3, you see here equation 3, 0 to nu m, 0 to nu m. 0 is a lower frequency, nu m is maximum frequency, so it will be 4 pi V of 1 by C1 cube plus 1 by C2 cube into nu square d nu, which is equal to 3 nu, where nu m is the maximum frequency in the range of 0 to upper limit value nu m. Therefore, the above equation 3 is changed into, after calculation, 4 pi v, 4 pi v of 1 by c1 cube plus 1 by c2 cube into nu m to the power of 3 by 3, nu m all to the power of 3 by 3, which is equal to 3n. This is nu square is integrated from 0 to nu m, which is nu square change into nu cube by 3. So the above condition, again it will be simplified as 4 pi v of 4 pi v of 1 by c1 cube plus 1 by c2 cube. So 3 3, which will be 9m, nu 3m is changed into right side you take, it will be 339. So 4 pi v of 1 by c1 cube plus 1 by c2 cube, which is equal to 9n by nu m3. So here nu m is nothing but maximum frequency, It is nothing but maximum frequency. For the simplification, 1 by C1 cube plus 1 by C2 cube. 1 by C1 cube plus 1 by C2 cube is changing the value to 9n by 4 pi v nu m all to the power of 3. Nu m, maximum frequency of power 3. So 1 by c1 cube plus 1 by c2 cube is changed into equation 4, which is equation 4, 9n by 4 pi v nu into, nu m into whole power 3. So the whole power 3 is for only maximum frequency. That means nu m only, not for the entire term. It's for only nu m. That's it. So this is we consider as equation 4. So here what is equation? This is an equation 4. Substitute equation 4 in equation 2. What is equation 2? Let's see. What is the equation 2? Equation 2 is, this is an equation 2. Is it right? Nu n of nu d nu, which is equal to 4 pi v of 1 by c1 cube plus 1 by c2 cube into nu square d nu. This is equation 2. So now substitute this above equation, which is equation 4. Substitute in equation 2, then n of nu d nu equal to 4 pi v. 4 pi v, and replace the value of this one. It will be considered as 9n 4 pi v vm cube nu square into d nu. Nu square into d nu. Simplify. This is what? This is your value. So in the place of 1 by c1 cube, 1 by c2 cube, you replace this value. Then it will be what? It will be n of nu d nu equal to 4 pi v. 4 pi v into 9n by 4 pi v nu m all to the power, only for the 3. The 3 is only for nu m. Nu m all to the power of 3 into nu square dv. Again, if you are simplifying, 4 pi will be cancelled, vv will be cancelled, and finally what you will get? You will get 9n nu square into d nu by nu m all to the power of 3. Nu m all to the power of 3. So what is that? N of nu d nu equal to 4 pi v into 9n into nu square d nu by 4 pi v nu m all to the power of 3. Only for the frequency. This all to the power of 3. After simplification, 4 pi will be cancelled, vv will be cancelled, and remaining is what? Only nu m. 9n into nu square into d nu by nu m all to the power of 3. This is we consider as equation 5. N of nu d nu equal to n of nu d nu equal to 9n nu square into d nu by nu m all to the power of 3. According to quantum theory, the energy associated with each degree of freedom is energy associated each degree of freedom. On the basis of quantum theory, Einstein introduced is specific heat of theory. Dulong-Petila is considered on the basis of classical theory. On the basis of quantum theory, Einstein introduced specific theory of solids. So here, according to quantum theory, the energy associated with each degree of freedom is what? It is h nu by exponent h nu by kt minus 1. H nu by exponent h nu by kt minus 1. H nu by exponent h nu by kt minus 1. The total energy in the solid for the frequencies nu and nu plus d nu is what? The total energy in the solid for the frequencies nu and nu plus d nu plus d nu is given what? U equal to 9n by nu m all to the power of 3 only for the frequency nu m 3 into replace the value of that one h nu cube by exponent h nu by kt minus 1. The total energy U equal to 9n by nu m3 into h nu 3 by exponent h nu by kt minus 1 into d nu. Therefore, the thermal energy released or associated in the solid is U equal to 9n nu m3 integration h nu 3 by exponent h nu by 3 h nu by kt minus 1. 9n by nu m3 exponent h nu 3 by exponent h nu by kt minus 1 d nu, which is equal to equation 6. Here you need to consider some of the assumptions. Let us consider x. Let us consider x. X equal to what? X equal to h nu by kt. X equal to h nu by kt. That means nu equal to is what? Nu equal to kt by h into x. Therefore, what is d nu? D nu is nothing but kt by h dx. Is it right? X equal to, let us consider x equal to h nu by kt. That means nu equal to kt by h into x. Kt by h into x. Therefore, nu equal to d nu equal to kt by h dx. D nu equal to kt by h dx. Also, theta d, here theta d is nothing but Debye temperature. Debye temperature theta d by t equal to h nu m by kt. H nu m by kt. Nu m is what? Maximum frequency. Theta d by t. Theta d is what? Theta d is Debye temperature constant. Theta d by t, which is equal to h nu m by kt. Therefore, nu m equal to what? Theta k by h. Maximum frequency is what? Theta k by h. Substitute the values of x and theta in the equation 6. What is the equation 6? Equation 6 is what? This is equation 6. Here you substitute the values of theta. You substitute the values of, sorry, not theta. Substitute the values of nu m. Then what you will get? See here. D nu and nu m. D nu is what? Kt by h into dx. And nu m is what? Theta k by h. Substitute these values of x and theta in the equation 6. Where? In the equation 6. Then 9n by theta 3 k3 by h cube. 9n theta 3 k3 by h cube 0 to integration 0 to theta d 0 to theta d h nu cube into kt into dx by exponent x minus 1 exponent x minus 1 into x, sorry, not x, h. So therefore u equal to, you simplify here, it is 9nk 9nk h cube nu cube k3 t3 bracket half t4 theta power 3, simplification, after simplification it will be theta power 3 t to the power of 4, and the integration from 0 to theta d 0 to theta d, which stands for 1 by exponent x minus 1 dx. Simplify, you will get, after simplification it will be considered 9nk h cube nu cube by k3 t cube into t4 t3 integration 0 to theta d 1 by exponent x minus 1 dx. For getting a molar specific heat, for getting molar specific heat, here R equal to what? R equal to nk. In Debye, in Dulong Petty, it is NAK. Na means Avogadro number. Here in Einstein, it is only number of atoms. So here, for getting molar specific heat, R equal to NK, that we know, but we are not using here. So after simplification, the above equation is changed into 9nkt. You simplify here, 9nkt, t power 4, t power 3 will be cancelled, and whatever you have, what you have, t to the power of, you simplify theta d. So here, after simplification, it will be considered as x cube by e to the power of x minus 1 dx. So this is about the specific heat. So this is an equation for the specific heat. Equation for specific heat. U equal to nkt t by theta d, t by theta d all to the power of 3 into 0 to theta d into exponent, sorry, x to the power of 3 by e to the power of x minus dx. If you are simplify that above equation, you will get this one, you will get this one. After simplification, we are getting this equation. So this is called as, this is called as that, this is called as Debye equation for internal energy or specific heat. So here it will be considered at high temperature, it will be considered as Cv equal to du by dt 3nk. At high temperature, the Debye concept is changed to the Dulong Petty. It is approach to the Dulong and Petty. It is approach to the Dulong and Petty. E to the power of x is equal to 1 plus x. So you replace the value c1, then it will be, what is that one? It is, after simplification, it will be considered as 9nkt will be changed into 3nkt, where nkt is nothing but, nk is nothing but r. So here du by dt. So here t to the power of 3, this one will be simplification, the entire value e to the power of x. So here what I am going to means, here the value will be x to the power of 3, x to the power of 3, it will be simplified, then 3 9 by 3 means that only 3, So after cancelling everything, you are getting Cv equal 3 at high temperature. It moving to the approaching to the Dulang and Petila. At low temperature, the value is considered Cv equal to 12 by 5 or pi to the power of 4 into T by theta d all to power of 3. So finally we can conclude that one in Debye theory, the internal energy will be proportional to the t to the power of 3. Or if you are taking du by dt, then du by dt means what? Specific heat. The specific heat is proportional to the t power 3. T power 3. That is specific heat what? Here you are having only u value. Is it right? So if you are du by dt, if you apply the application, if you apply the mathematical calculation, du by dt is what? Du by dt. So du by dt is nothing but c. Du by dt at constant value, that is cv. So at constant value, the cv value is what? It is proportional to the t to the power of 3. It is proportional to t to the power of 3. It is proportional to t to the power of 3. This is called as power t power 3 law. Sorry, t power 3 law. T power 3 law. That's it. Thank you.